When we talked about balancing reactions, one of the things on the gizmo that we saw asked us about s'mores. And the question was, what's wrong with this picture? And the answer is, you can't make 4 s'mores from those ingredients. So let's talk about how to make a s'more. For a s'more, you need 1 marshmallow. These chocolate pieces, you tend to use 1/4 of a chocolate bar, and there's 12 little rectangles in there, so we're going to call it 3 chocolate pieces. And you need 2 graham crackers. And all of that together makes 1 s'more. So what if you want to make s'mores for the entire class, and there are 20 people in the class? Okay, if I want to make 20 s'mores, how many marshmallows am I going to need? If you said 20, you are correct. How many chocolate pieces am I going to need? If you said 60, you are correct. How many grams? I'm going to need 40 grams. Okay? This is stoichiometry, figuring out how much you're going to need in order to get a reaction to go. And what you're doing is easy because you can see this in your head. But when we get to moles, for whatever reason, stoichiometry, people don't quite see it. All right? So if you get your mole map out, on the back of your mole map, we have a mole bridge. In order to go across the bridge, you have to be in moles. All right, we know we can do grams. We can figure out grams to moles. We can figure out particles to moles. So anything that if you're going to do a stoichiometry problem, anything you're given has to be converted to moles to start the equation. All right, and we use a something called the mole ratio, where we have our known amount. We start with our known amount, and we multiply it by a ratio of what we're trying to solve for to what we know that we get from balancing equations. All right, let me give you an example. In the earlier equation, I said we wanted to make 20 s'mores. All right, the question is, how many graham crackers will that take? Okay, well, you guys can look at that and go, oh, 2 graham crackers makes 1, so 40 is going to make, or 4 would make 2, and if you want to make 20, you'll need 40 graham crackers. Well, this is how you do it with stoichiometry. You take your known amount, 20 s'mores, you look at your equation. 1 s'more requires 2 graham crackers. So we're going to make a ratio. 1 s'more is our known amount. It goes on the bottom of our ratio. And 2 graham crackers is our unknown coefficient. So these numbers here are coefficients. All right, and there's a multiplication sign right here. So you start with what you know, and when you multiply it by that ratio, you will get the number of graham crackers. That's our unknown. That's what we're solving for, which is 40. Well, what if I gave you something a little trickier? What if I tell you that we have 63 chocolate pieces? And I want to know how many s'mores that's going to make. So my unknown is s'mores. 63 chocolate pieces. What's my ratio of chocolate to s'mores? Well, that ratio is 3 to 1. But chocolate is my known. So I'm going to put chocolate on the bottom of my equation. And on the top, I'm going to put, it takes 3 pieces to make 1 s'more. Now I can cancel chocolate out. 63 times 1 over 3, so now I have to do math in my head, 21. That will make 21 s'mores. Okay? That's what we're going to do with stoichiometry. We're just simply looking at mole ratios. And today we're not going to worry about getting on our bridge. We're just going to go across the bridge. So if you look at the worksheet in your packet that's entitled Mole Stoichiometry, it starts out with an equation, and we have a balanced equation. And it tells us we have 12 moles of potassium chlorate. So that's our known amount. So I'm going to come back up here. 12 KClO3 is our known amount. We are solving for oxygen. So oxygen is our unknown, and now we need to multiply 12 by that ratio, the unknown over the known. So oxygen in that equation requires 3 oxygens for each 2 potassium chlorates. So if I take 12 times 3 divided by 2, I get 18 moles of oxygen, if I've done my math right. Okay, so what I suggest is that you get out a highlighter and that you highlight the known information and highlight in a different color the unknown. Here's the known, 12. My unknown is going to be in green. How many moles of oxygen? Now lay the problem out. 12, and I want this one. I don't know why I keep hitting the wrong one. 12 moles of KClO3 is our known amount. We're going to multiply that by our ratio, and our ratio is just the coefficients unknown over known. So the coefficients are 3, because that's what we're solving for, over 2. 12 times 3 would be 36, divided by 2 would be 18 moles of oxygen. Okay, let's go to the next one. My known amount is 2.5 moles of potassium. My unknown amount is potassium chloride. So we'll start with what we know, 2.50 moles of potassium, and I'm going to multiply that by my ratio of unknown over known. This is my unknown. 2 moles of KCl will react for 2 mole, or will be formed for every 2 moles of potassium used. So that cancels out to 1. So if we start with 2.5 moles of potassium, we will make 2.5 moles of potassium chloride. The next one, our known amount is 1.20 moles of sodium oxide. Our unknown amount is moles of sodium hydroxide. So first we start with our unknown amount, or our known amount, 1.20 moles of sodium oxide, and I multiply by the ratio, and we do unknown moles on top of known moles. So unknown is 2 NaOH. I don't know why that's there. Over 1 mole of Na2O. So that would be 1.40 moles of NaOH that we would form if we start out with 1.2, or if we start out with 1.20 moles of sodium oxide. The next one, our known amount is 16 moles of sulfur. And our unknown amount that we're solving for is moles of iron. So we're going to start with our known 16.0 moles of sulfur. And the sulfur comes in packages of 8 in this case. The ratio of iron, the unknown, over sulfur, the known, is 8 to 1. 8 moles of iron will react with 1 mole of sulfur 8. And that gives us, and I'm going to have to cheat and use a calculator, 16 times 8 is 128 moles of iron will be needed to react with 16 moles of sulfur. The next one, again, our known amount is 12 moles of sodium chloride. Our unknown that we're solving for is moles of oxygen. So we start with 12.00 moles of NaClO3. My ratio is 3 unknown over 2 known. NaClO3 cancels, and we end up again with 18.00 moles of oxygen. Why I have virtually the same problem between question 1 and 5, I'm not sure. The only difference is the sodium instead of potassium. The next one, our known amount, what we're given, is 3.5 moles of silver nitrate. And what we are solving for is how many moles of copper. So if we start with 3.50 moles of silver nitrate, and we multiply by our unknown, which is 1 mole of copper, over our known, which is 2 moles of silver nitrate. 3.5 divided by 2, don't judge me because I had to do it on a calculator. 1.75 moles of copper will be required. The last one, 2.5 moles of pure Fe2O3 iron 3 oxide are used. We want to know how many moles of iron we're going to make. So for this one, we'll start with 25 moles of iron 3 oxide. Our ratio is unknown over known, 2 over 1. And in the end, we get 50 moles of iron. All right, that's your introduction to stoichiometry.